Making an automated process is good when you have an end-to-end set of steps that doesn't require any thought whatsoever. This could include automations like getting information from one location and creating a report from that data. But what happens when we need to make a decision based on that data? That's where conditional statements come into place. Before we discuss conditional statements, we need to discuss what kinds of decisions a bot can make. Decisions based on data or black and white business logic are ideal. Decisions based on fuzzy data or feelings are much more problematic. While tools like AI and keyword searching may be able to assist, that level of decision-making isn't where automations really thrive. The planning stage of building your automation needs to define these decisions before the bot is going to be built. And the more that you can make those decisions black or white, the better. Let's start by building a simple automation that will read through some data within an Excel workbook, make some simple decisions, and write updated information to the same workbook. Let's start by downloading a fresh copy of this workbook from our training server. If you open this workbook, you'll see a list of names, company names, and current salaries. There's also a column for a new salary. We will calculate salary increases using this list, but we'll make some decisions based on which company they work for and what their current salary is. If the employee works for Nanotech and their salary is less than $40,000, they will get a 10% increase. Otherwise, they'll get a 5% increase. If the employee works for Picotech and their salary is less than $40,000, they will get a 15% increase. Otherwise, they will get a 10% increase. If the employee works for Microtech, they'll get a 5% increase regardless of salary. Now back at the control room, let's create a new automation by clicking the Create a New Task Bot button. The name for this automation is Conditional Salary Increase, and click the Create and Edit button. Starting with the Excel Advanced package, add an open action to your automation. On the right side, make sure that File is selected, then Desktop File, then browse to your salaries.xlsx file. Tick the box "This sheet contains a header," and at the bottom, make sure that local session is selected and that the name is default. After the open action, add an Excel Advanced Go to Cell action. We will use this to position our cursor where the updated salaries go within this workbook. On the right, for the specific cell, enter E2. After the Go to Cell, add a loop action from the loop package, and on the right side, let's leave this as iterator. Then in the iterator dropdown, select Excel Advanced for each row in a worksheet. We want to loop through all rows, so we won't change that a bit. I am going to change this read option to read cell value because I want to get the unformatted value of the salary, not the value with the dollar signs. In the Assign the Current Value to this variable, click on the X at the right side of the dropdown to create a new record variable. When the pop-up appears, put a lowercase r in front of Excel row. This is the naming scheme that we use here in training to let us know the data type of the variable quickly and easily just by its name. And then click on Create and select. As we read through each row of that data set, we read that row of data into the record variable. Now, since the record variable stores each column of data as a string, we need to convert the salary values to a number value so that we can do math and comparisons on that value. Within the loop action, from the string package, add a string to number action. In the Enter the String, click the X in a box, and from the Choose a Variable dropdown, choose the R Excel row variable. In the Record section, make sure that By Name is selected and enter Current Salary, and click Yes, Insert. That's the name of the column of data that we want to work with from the Excel document. For the Assign the Output to Variable, click the X in parenthesis to create a new variable. When we create variables on the fly, the correct type is chosen for us. In the Name field, enter in N for number, salary, and then click Create and select. It's now time to bring some if actions to this automation. This is one of the most common of conditional statements dating back to the dawn of computers. It allows us to do something if the condition is true and, optionally, do something else if the condition is false. Notice there's no ambiguity. It is always a black and white condition. From the if package, add an if action after the string to number. And we're going to start with the easiest condition. If the employee works for Microtech, they will get an unconditional 5% raise. Under Condition, choose String Condition. For the source value, click on the X in a box, choose the R Excel row variable. By name, and enter company in the text box. And click Yes, Insert. We're going to leave the operator as equals to, and then in the target value, enter Microtech. You may uncheck the Match Case checkbox to make the comparison not case sensitive. Now within this if, from the number package, let's add a toString action. This action allows us to perform some math and convert the value to a string variable all at once. We need to make sure that the value is converted to a string because when we put the value into Excel, Automation 360 is expecting a string variable. In the Enter a Number field, click the X in the box, choose End Salary from the drop-down list and click Yes, Insert. Now, immediately following that salary, add in asterisk 1.05. This is what calculates that 5% salary increase. We'll change the number of digits after the decimal to 2. And then for this first number to string, we do need to create the string variable where the updated salary will go. So click on the X in parenthesis on the right side. And for the name, enter S for string salary. And click Create and Select. This takes care of the Microtech employees. Now onto the Nanotech employees. The Nanotech decision is a little bit more complex. We need to check their company name just like we did with Microtech, but we also need to check their salary. To do this, we will have an if action within an if action. This is called nesting ifs and can be used to whittle down the data into smaller decisions, making it easier to code these decisions. After the previous if, and be careful where you place this, we don't want to have this if inside that one, add another if action. Like before, on the right side, choose the string condition. For the source value, click the X in a box. Choose that R Excel row variable and enter company and click Yes, Insert. Leave the operator as equals to, and then in our target value box, enter Nanotech and uncheck the Match Case checkbox. Inside this if that we just added, let's add another if within it. This is our first instance of nested if actions. The condition of this if will be a number condition. For our source value, let's click the X in a box and choose N salary and click Yes, Insert. This time, we'll change our operator to less than. And for our target value, enter 40,000. Don't put any dollar signs or commas for thousands or anything here. Now this sets us up for people whose salary is less than 40,000, but what about those whose salary is not less than 40,000? This is where the else action comes into play. This allows us to perform different actions when the condition is not true. From this if package, add an else action right next to the if. Notice the else action does not have any parameters on the right side of the screen. It always handles the negative condition from the if action. In this case, we have two places to set the salary increase: the if side and the else side. Starting with the if side, add a number to string action. And this is what will calculate the raise for those whose salary is less than $40,000. For the Enter a Number field, click the X in the box and choose N Salary, and click Yes Insert. After the variable, add asterisk 1.1 to calculate the 10% raise. Enter 2 for the number of digits after the decimal, and assign that output to variable S salary. Notice we didn't have to create it again this time since we had already created it previously. To make this easier, we can do some copy and paste. We can use the three-dot menu and select Copy Action. For the else, we can use its three-dot menu and paste inside action. Now all we have to do is modify the multiplier from 1.1 to 1.05. The rest stays the same. We can do an even bigger copy and paste with the entire if action. So up at this if action, use its three-dot menu and select Copy Action. I'm going to scroll up to this string to number action up here, use its three-dot menu, and select Paste After Action. Since the order of these actions doesn't matter, pasting this if after the string to number is actually just a little easier. All we have to do is make some modifications. So for the if action, let's modify the company name to Picotech. Let's change the modifiers for the if action to 1.15, and the modifier here to 1.1. To finish this automation, let's go after the last if action, and from the Excel Advanced package, add a set cell action to your automation. Make sure you add that after the if action. We'll leave the cell option as active cell, and for the cell value, click the X in a box and choose S Salary, and click Yes Insert. We need to move our cursor down to the next row of the Excel document. So add a Go to Cell action right after the set cell. On the right side, choose Active Cell, and from the drop-down, choose one cell below. And that's all we're going to do for this automation. We're leaving the Excel file open so we can see the results, but completionists may add an Excel Advanced Close action after the loop to save and close the file. Make sure your Excel file is closed, and let's run our automation and see what we get. So what did we learn here? The if action allows us to make a decision based on the condition specified. Most of the time, conditions are based on a value stored in a variable. but they can be things like check if a window is present, see if an application is running, see if objects are present on the screen, and much more. The else action handles the negative condition of the if action. If actions can be nested within other if actions for even more complex logic. Thanks for watching, and go be great.